Alright, so our last problem that we want to address is limiting reagent. And these are important problems because you might run into this in the lab. So, say I had to use really ultra pure water for this reaction, and I only have 22 grams of ultra pure water in the lab, that it would take me till tomorrow to make more. So I'm limited there, and then I go to my shelf and I say, oh no, I only have 12 grams of my nitrogen dioxide as well. And I wonder, I'm like, which one of these things am I going to run out of first? This would be a limiting reagent problem. And so we can address this by looking at a gram to mole conversion, and then we do a mole to mole conversion, and then the mole to gram conversion one more time. And we compare it with the grams that we actually have, and then we see, is it going to run out first, or is the water going to run out first? So let's go ahead and set this up and work this problem out. So we're going to start, it doesn't even matter which one you pick to start from. You can go from this one to this one to this one, or you can go from this one to this one to this one. It doesn't really matter. We'll just go from this one to this one to this one and try it out. So we're going to start with our 12 grams of NO2, and we know to be able to compare it with our grams of water, we're going to have to convert it into moles first and then convert it into moles of water. So we do our first conversion, we're going to need to get rid of grams, so grams is going to have to be on bottom, and our mole is going to have to be on top. So we'll have moles of NO2, grams of NO2. To get the grams of NO2 per mole, what do we have to calculate? That's right, the molar mass. It keeps coming back. So our NO2, we've got 14 plus 2 times 16. That's 46. So we've got 46 grams per mole. So we're going to calculate how many moles of our nitrogen dioxide that we have. This comes out to 0.26 moles. 0.26 moles of NO2. So that doesn't really help us yet. So we need to calculate how many moles of water that we would need to react with those moles that we have of our nitrogen dioxide. So we need to now calculate moles of water from this value. So we start out with 0.26 moles of NO2. And we can see that our conversion is going to be 1 to 3, right? So that's a coefficient of 1 in front of our water molecule up there. So we know for every 3 moles of NO2, we're going to need 1 mole of water. So we can put 1 mole of water on the top, because that's what we want to calculate, for every 3 moles of NO2 that we utilize. Those will react perfectly well. So we can calculate moles of water using this equation and conversion factor, because our moles of NO2 gas are going to cancel out. And so we calculate that for 0.26 moles of NO2, we only need 0.087 moles of H2O. So now we need to see if 22 grams is equivalent to that amount. So we would have 0.087 moles of water. We need to convert this into grams of water. And we know we need the formula weight then to do this conversion. So our formula weight of our water molecule is going to be 1 times 2 plus the 16, where that's going to be equivalent to 18 grams per mole. So we can see if we've got 12 grams of our NO2 gas, we're going to need at least 1.56 grams of water to react with that. So now what we do is we do a comparison, right? I need 1.56 to react fully with our 12 grams here. I actually have 22 grams. So I've got way more water that I'm going to use up. I'm going to run out of the nitrogen dioxide first. I've got a lot extra of the water molecules. So in this case, my limiting reagent is NO2. I'm going to run out of that guy first in this chemical reaction. So that's an example of a limiting reagent question.